All right, hopefully you have thought about it. Let's now turn to some illustration quickly. All right, so over here, again, we got precondition, we got postcondition, we got implementation. So precondition and also postcondition is the specification. And also we got the implementation over here, along over here. Can be arbitrarily complicated. And now, let's make the following assumption over here. Because eventually we may want to suggest some fixed, right? Before that, I just want to make the cases simpler. Let's make the following assumption to say the implementation and also the postcondition. Let's say these two are fixed, meaning that we don't change them. Assume. So these two are simply fixed, which means not subject to change. Let's make that assumption. Having said this, based on what we learned previously about the correctness of program, right? You can review these two definitions over here. So now, what will be the guiding principle for us to judge for this different example? So the guiding principle would be, let's put it down. Guiding principle. The guiding principle would be your precondition cannot be too weak. The precondition cannot be too weak. Let's make it very explicit what I really meant. i.e., it does not allow any input value that can cause a postcondition violation. So this will be the guiding principle over here. So it's really important. We are talking about the precondition. The precondition over here cannot be too weak, right? Too weak meaning that it should be the weakest maybe it's the weakest possible, but it cannot be any weaker, right? But don't worry about the weakest possible, but not weaker. I should really delay the discussion about this notion maybe a little bit later. Just think about it cannot be too weak. How can you show that a precondition is too weak? As long as you can find any value that can actually cause a postcondition violation. So this will be the important points to actually to note. Okay, for example, previously the precondition is simply too weak because now if you choose the value 4, which is allowed by this particular precondition over here, in that case it's going to cause a postcondition violation as we illustrated. All right, so that's a guiding principle. Let me move on a little bit more. So now, is this the case right now for this particular program? Well, let's see. When we say I is larger than 5, so this is the precondition. So what are the valid values over here? You can think about a set of satisfying values would be, you got 6, that should be the smallest, right? The smallest valid input value. 6, 7, and 8, and 9 over here, right? And etc. All the way to the maximum possible integers for your computer. So now let's try over here. You can easily try to see if 6 was chosen, 6 will satisfy precondition, 6 plus 9 will be 15. 15 is larger than 13, so that's not a problem. And now if you try 7, it's even the case because it's just a larger input. 7, let's just do one more. 7 satisfy the precondition, 7 plus 9 will be 16, 16 larger than 13, so we are still fine. So it seems like all the allowable input values that would satisfy this particular precondition is guaranteed. Upon termination, the postcondition will not be violated, or the postcondition will simply just be satisfied, right? It seems like this set is okay. Okay, but I would like to discuss just a little bit about it. Okay, so let's say all values satisfying this precondition will guarantee the satisfaction of the postcondition. Of course, we also assume the implementation that's given over here, right? So that's also the implementation given over here, right? Just want to make a note over here. Over here, will guarantee the satisfaction of postcondition after executing the implementation. Let me make it clear, make it complete. Okay, and then so this will be after executing the implementation. All right, so now it seems like this program here is correct. Okay, so now that's the conclusion is, first of all, this program here is correct because you cannot find any input value that's allowed by the precondition that will actually cause a postcondition violation. You just cannot find one. So this is correct. However, notice one thing one more discussion about this particular example. Since we talk about this particular one, I wonder if this precondition over here might be too strong, which means it kind of exclude certain value that could have been included. For example, what about 5 over here? Let's say input 5 over here, apparently 5, currently 5 larger than 5 is simply false, which means it will not be allowed in order for executing the body of the implementation. However, is 5 really going to cause any harm? That's the question, right? So now, hypothetically, let's say if 5 is not going to violate the precondition violation, if you simply say 5 plus 9, that's going to be 14, and 14 larger than 13 will still be okay. So which means, why was 5 not included, right? So that's something I would like to say over here. So let me just simply just put another discussion over here just to finish off this particular example. Okay, just over here. Is I larger than 5 too strong? Because the input value 5 over here that's currently being excluded will not cause any postcondition violation. Postcondition violation. Apparently, right? Let's now see. So I'm just posing this question over here for you to think about. So now, should the fact that I larger than 5 is too strong, do you think that will cause the entire program rather than being correct into incorrects? The answer is not necessarily. All right. So now let me just put a conclusion over here. Okay. So whether an inputs should be included, in this case the value 5 over here is up to the requirements of your particular design or the requirements of your particular application. So it's really whether for your particular requirements, if 5 should be excluded, then this precondition is absolutely fine. If for your particular application 5 should have been included, in that case your precondition over here is really way too strong. All right, so I would say the correct over here is assuming that five should be excluded. If based on your requirements 5 should not be excluded, in that case this program here will be incorrect. All right, so I think both of the examples that we try to speak about just as motivating scenario would be, you want to really think about given the contracts and the implementation, you want to strike a balance between having the exact precondition that's not neither too weak nor too strong, and then you try to see upon the termination of the implementation, can the postcondition be satisfied. All right, let me make a recap and then we are done with the first part of this lecture. So this particular example here, having this particular precondition which excludes 5 over here, as is, it seems to be correct because all the valid input 6, 7, 8, 9, they are not going to create any postcondition violation. So the program is correct. However, you want to think a little bit deeper to think about, since input 5 also will not cause any postcondition violation, but somehow the current precondition seems to be a little bit too strong, such that it excludes the input value 5. So now, should this exclusion be a cause for the program being correct or incorrect, right? So that's the real question we want to ask. So I would say there's no absolute answer over here. So it really depends on the requirements of your particular development context. If the development context says that the input 5 should be included, in that case, this program here is not really correct because the precondition is way too strong. On the other hand, if 5, according to the requirements, should not be included, in that case, this precondition is just okay. All right. Anyway, study again the details for this example over here before we move on to going over some definition for software correctness.